Our online lesson brought to you by Yaaka. I'm Teacher Ashaba Frederick. So today we are going to look at the dynamics of the particle, and our emphasis is on those particles that are moving in a straight line. So on this screen here, we have two diagrams, and I think some of us are familiar with them. So who can tell us what they see in the first diagram? What do we see in the first diagram? We are seeing nothing. Are you able to see my screen?
Yes.
Okay, so what are you seeing?
Like something. Is it like a car?
Yes. And it has about 4 forces that are acting on it. Okay.
Yes.
So we have the reaction force that is acting upwards. We have the weight of the car, which is 5,000 newtons. Then we have the driving force, which is 1,800 newtons. And then we have the mu r force, which we call the friction force, that acts in opposites. Okay, that force that tries to oppose motion. Then on the second diagram, we have an incline. So we have a particle M1 that is inclined at an angle of beta to the horizontal. Then we have a particle M2 which is also inclined at an angle alpha to the horizontal. And these two particles, M1 and M2, are connected by a string that is passing over a fixed pulley. So all these particles in the diagram 1 and diagram 2, we expect that there is motion that is going to occur in these two particles. So that is what we are going to majorly look at in this topic, in this lesson today. So we are going to look at those particles that are in motion. So in the introduction, we are saying this chapter teaches you how to deal with forces acting on an object, learn about how to use several formulae inspired by Newton, Isaac, learn how to model situations involving friction, particles moving on slopes, and when joined over pulleys. We'll also learn laws of momentum and impulse. So we are beginning, all of us know that Newton's second law of motion is the force equaling to ma, and that is what we shall majorly use in our discussion today. So I'm saying the force needed to accelerate a particle is equal to the product of the mass of the object and the acceleration required, which is the second Newton's law of motion. of F equaling to MA. So that is what we shall majorly use today in our discussion. So force is measured in newtons, which is the standard unit. And the newton is a force that will cause a mass of 1 kilogram to accelerate at 1 meter per second squared. So that is the simple definition of a newton. For some of you who do physics, you know much better. So it is a force that causes a mass of 1 kilogram to accelerate at 1 meter per second squared. So let us begin with a simple illustration here of a body resting on surface. So this body will have some forces acting on it. So we are beginning with the reaction, the normal reaction. So we're saying the normal reaction acts perpendicular to the surface which an object is resting on. So perpendicular meaning it is 90 degrees. So who can read for me this second statement here, which begins with it is equal? Yes, Trevor. Yes, Ashnant.
It is equal and opposite to the force exerted on the surface by the subject, which is determined largely by, teacher, I can't say that word, and the mass of the object.
By gravity. So we are saying this normal
By
reaction
gravity.
And mass of the
And
object.
the mass of the object.
Okay, thank you. So this normal reaction force is perpendicular. So any object, even us, we have weight. And that weight, we get it by getting mass times the acceleration due to gravity. So this acceleration due to gravity acts towards the center of the Earth, and that is why this arrow is moving downwards. So that is mass times G, mg. So where you meet G in mechanics, it means acceleration due to gravity. Then the reaction force, we said it acts upward, it acts perpendicular to the surface on which it is resting. So for it acts upwards, and we call it R. So we are saying the table matches the force from the brick, which is why the brick remains still on the table. So in brackets, there is no cos. There is, of course, would be a maximum possible weight that could take place, but we're not, don't worry about this for now. So for now, this body here is not moving because we have not subjected it to any other forces. Then when we come again now, we are going to see, so we also have frictional force. So what do we understand by the word friction? What do we understand by the word friction? Yes,
Friction is a force that opposes relative motion in a body.
A force that opposes relative motion. So for it, it acts in a opposite direction where the force, where the body is moving. So for it, it acts in the opposite direction because for it, it opposes motion. So I'm saying the frictional force opposes motion between rough surface. So when the surfaces are not rough, so when they tell you it is a smooth surface, then there is no friction there. So if that is the direction of motion, then our friction will be acting in this direction because for it, it opposes. So it will be moving in the opposite direction. So that will be the frictional force. So I'm saying although it is a force, friction does not cause movement in its own direction. It just reduces the effect of another force. So this frictional force does not make this particle or body here to move in this direction. So what we are saying, it just reduces the effect of the direction of motion. So it reduces on the speed of the movement. So I'm saying surfaces have a maximum level of friction where it is unable to completely prevent movement. So after some time, when we apply an adequate force, the body will be able to move when it overcomes the friction. Then we have tension. So tension is a force. We're saying if an object is being pulled along, for example, by a string, the force acting on the object is called tension. So when you tie an object to a string and then you pull the object using a string, so the object is now being pulled by a force that we call tension. So the tension force is only in strings and the springs. So as you try to stretch them, they will tend to come back to their normal position, and that is what we call tension. So that force that keeps them in their original position is the force we call tension. So that would be the tension force in a string when the body is being pulled by a string. Then we have thrust. Oh, the words are small. Okay. I will send you the notes after the lesson. Don't mind about the words being small. So if an object is being pushed along, for example, by a rod, then the force acting on the object is called thrust, or sometimes compression. So here we are trying to push. So if we are pushing an object, then the force we are using is called thrust. So tension here is equal to the pushing force. So it's here, it is indicated here. So when we are pushing, so that force is called thrust. All then we have resistance. So resistance is different from frictional force. So the resistance can be in any of the directions. So as much as it also acts in the opposite direction, but for it is different from friction. Because we saw that for friction to occur, there is a condition which condition is that the surface must be rough. But for resistance, the surface may not be rough. It may be because of air and etc. So an object moving through air, fluid, or a solid will experience resistance caused by particles in the way. So when you drop a particle into water, so it moves slowly. So it moves slowly compared to how it would move in air. So that means in water, it is experiencing some resistance. So it is even in a fluid or in a solid. So it will experience resistance to its movement. Then we have gravity. So that one we had briefly talked about it. So that it is that force that pulls an object towards the center of the earth. And it is given by G. So the force caused by gravity acting on an object is called its weight. So we said if an object is being pulled towards the center of the earth, the force that we get is weight, which is equal to mass times acceleration. So we are saying that we remember Newton's formula of F equaling to ma because we are going to use it. So the force is called weight. M is the mass, and the acceleration due to gravity is 9.8, or we can take it just as G. So W is equal to mg. So when we come to the part of resolving, when there are multiple forces acting on an object, we resolve these forces in different directions, like we did in the previous, where we resolve vertically and horizontally. Then one direction will usually be in the direction of acceleration, so which we take to be like the positive. The other will be perpendicular to this, so the other direction will be at 90 degrees to the direction of acceleration or direction of movement. So here we have a summary of what we have gone through. So in the first diagram, we have normal reaction R, that is equal to mg, which is mass times gravity. In the second one here, we have direction of motion, and then we have a frictional force that acts in the opposite direction. In the third, we have tension if we are pulling the body or the object by a string or a rope. And then the fourth is when we are pushing the body. So these are just the summary of what we have just talked about. Please, if you have any questions, you just raise up your hand, I will be able to see, or you just type in the chat. So now let us go to our calculations. So we are saying find the weight in newtons of a particle of mass, which is 12 kilograms. So we said weight is equal to mg. So we shall just say F is equal to ma. And then the mass is already in kilograms under acceleration. And we use acceleration due to gravity, which is g, because this of our particle being in kilograms. So we need its weight. So we know that weight is equal to mg, which is mass times acceleration.
Yeah.
So that would be 12 times 9.8. And those of us who have a calculator, or those of us who are very good at using our heads, we can generate an answer. Of 12 times 9.8, 1.
Teacher,
Yes,
it's 117.6.
117.6.
Yeah.
Okay, thank you. Any other?
117.6.
Okay. Okay, thank you. So it is 117.6 newtons. Then we have another one. Find the acceleration when a particle of mass 1.5 kilograms is acted upon by a force of 6 newtons. So here we are given mass and the force, and we are asked to find acceleration. So what are we going to do? By a show of hands. Yes. Ashnant. Yes, Faith.
From force equals to MA, we can
Yes.
decide to make acceleration the subject, which is acceleration equals to force out of mass.
Yes.
Or we can just substitute in the first formula of F equals to MA.
Okay, thank you. So use F equaling to MA, and then we substitute. The F is 6, and the M is 1.5. So after that, we are going to divide by 1.5 both sides. And when we divide, we shall get an answer of 4. Is that clear?
Yes.
Yes,
Okay.
teacher.
Yes, teacher.
Then we continue to now this one that has 4 forces acting on it. And we have that the acceleration is moving in this direction here, is moving in the positive x-axis. So we have forces x, 4x, 2g newtons, and x. So we are requested to find the forces y and x. So here we are going to begin by considering the x-axis, or where the acceleration is acting, and we shall use so where the movement is going, so we take it to be the positive, and then we use F equaling to MA. So saying in this example, you need to consider the horizontal forces and vertical forces separated, and this is called the resolving. So we are beginning horizontally. So since it is moving in this direction, so this x here is going to be taken as positive and the 4 as negative. So we shall have when we substitute in, we must subtract any forces acting in the opposite direction. So the 4 is acting in the opposite direction. So we are going to subtract it from x. So it will be x minus 4, and it is equal to 2, because this 2 is mass of which is 2 kilograms, the 2, and then times 2, which is the acceleration. So that would give us x minus 4 is equal to 4. And now this negative 4 is going to cross the right hand side, and it becomes plus 4. And we shall finally get our answer as 8 newtons. Then when we resolve vertically we are going to have, since our motion is only along the x-axis, so we shall say we choose y as positive, taking it like in the xy coordinate, because this side of y is positive. So we say y minus 2 is equal to 2 times 0, because along this vertical we don't have any acceleration. The acceleration is only along the horizontal. So that is why the 2 is multiplied with the what? With the 0. And that would give us, by calculation, y minus 2g is equal to 0, because 2 times 0 is 0. And then our y will be equal to 2g, or when you substitute the g with the 9.8 and you get 2 times 9.8, your answer is going to be 19.6. Is that clear?
Yes, teacher.
So we have now this one where the direction has now changed. The force is now moving towards the negative x-axis. So now we shall take the 80 to be positive, and then the x to be negative. And then we have y moving upwards, the 20 Newton acting downwards, and then the weight of the body, which is 4g. So when we resolve, we are going to resolve vertically and horizontally. So resolving horizontally, so we take the direction of acceleration as a positive one. So that is why I said 80 is positive. So 80 minus x is going to give us 4, which is the mass, times 2. So 4 times 2, and 4 times 2 gives us 8. So 80 minus x is equal to 8. And then we collect like terms. And after collecting like terms, this 8 will move here and it becomes negative, and the x will move to the right hand side and it becomes positive also as well. So 80 minus 8 will give us 72, and hence our x will be equal to 72 newtons. And when we resolve vertically, so remember on the vertical we have a 20 Newton, we have the y, and a 4g. So when we resolve vertically and we take y as positive, this upper part, because of taking into consideration that the upper part of the y axis is positive. So we shall say y after substituting in the values. So y minus 20, okay? Because 20 is moving downwards, then minus 4g, because it is also moving downwards, is equal to 4 times 0. The 0 is because along this vertical axis, we don't have acceleration. Acceleration is only along the horizontal axis. So that is why F4 is multiplied by 0. And then when we calculate, 4 times 0 gives us 0. And then we have y minus 20 minus 4g. So adding the 20 and 4g on the right hand side, our y is equal to 20 plus 4g. And when you substitute for g as 9.8 and get 20 plus 4 times 9.8, you should be able to get this value of 59.2 newtons. I hope that is clear.
Yes, teacher.
Okay, thank you very much. I think we still have some 20 minutes. So, any questions?
Right, teacher.
Yes. Okay, let me get something else we could add, at least for some 10 minutes.
Walikwenda kwenda muzidi.
So this is a continuation of what we looked at. Those who have their microphones on, please help us and unmute them. So this is the part of what we covered the last week in the statics of the particle, where we are looking at movement, particles that are not in motion, that are stationary. So if we have particles here, and the particle is being acted upon by a number of forces, for example, P and Q. The Q is at an angle of 45 degrees. So if it is at an angle to the horizontal, we get the vertical and horizontal components of this force. So the horizontal component is going to be Q cos of 30. For us who remember some good trigonometry, that cos of an angle is adjacent divided by hypotenuse. So this is big Q cos of 30 and then Q sine of 45. Then here we still resolve vertically and horizontally using force is equal to MA. So vertically, so we have this Q sine 45, which is moving upwards, and then the 3G. So Q sine 45 is in the positive side of Y, so we begin with it, and then we minus 3G, and that will give us Q sine 45. The 3G crosses to the positive side, and when we divide by sine of 45, remember our G, I said, is acceleration due to gravity, and that will be 3 times that. So we shall have Q equal to 3G over sine of 45. And when we substitute in a calculator, it will give us, what do we get when we substitute 3 times 9.8 divided by sine of 45?
Get 578.
Yes? Yes, Simon?
We get 41.5778.
778. So which we can round off to 1 decimal point, give us 41.6. And then after this, we resolve. Okay. After that, we are supposed to resolve horizontally. So the horizontally P would be equal to Q sine of 45. And then we'll do the substitution and find the answer. So P is equal to Q cos of 45. So we already have the Q, which is 41.6 cos of 45. What would that one be equal to? 41.6 cos of 45. What would be the answer if we substitute in a calculator? Yes, Aggie?
You get 29.4.
29.4. Yes, 29.4 from the chat. Thank you, Simon. Okay, so we can proceed. And then we have a smooth bead. Y is laid on a right inextensible string. The ends of the string are attached to 2 fixed points, X and Z, on the same horizontal level. The bead is held in equilibrium by a horizontal force of 8 Newton acting in the direction Z, X. Bead Y hangs vertically below X and at an angle XZY is equal to 30. So we find the tension in the string and the weight of the bead. So what we do, we begin by drawing a diagram. And so that is XZ, which we say is the same horizontal level. And that is this is the bead here. And we call it Y. So this, we said it was below X. The bead is held in equilibrium. The ends were that. So remember, if this is an extensible string, it has a force that is in it. So also have this 8 Newton force here that is trying to keep the bead in equilibrium. So you're saying since this is only one string and it is inextensible, the tension in it will be the same. So it has the same what? Tension. So the tension in this portion of the string is equal to the portion to the tension in this other portion of the string. And then the mass, we don't know it, so we shall say it is M, and therefore this here will have a force, or a force of mg. And then we now begin resolving. So we create a horizontal here. And since this angle is 30 degrees, then we shall also have a 30 degrees here, okay? So it will create an equal angle because they are alternating. So this is 30, this is 30. So this tension here will have two components, the horizontal and the vertical. So what will be the vertical component? What will be the vertical component?
Y equals 30.
Y equals 30. Or I didn't hear it very well. Yes, Faith?
It will be T sine 30.
T sine 30. Sharon? Okay, so it will be T sine 30. And the adjacent and the horizontal one will be T cos. So after that, we resolve vertically. So vertically, we have the T, we have the T cos, and then we have the mg. So the T sine 30 and the tension alone are moving upwards, which is the positive side. So we shall take them to be positive. And then using F equaling to MA and substituting in the values. So we shall have T, this was horizontal, okay, horizontally. So horizontally we have T cos and 8. So T cos minus 8 is equal to 0. Then T cos of 30 is equal to 8. We divide by cos of 30. And after by calculation we shall have T as 9.82. Then after this we are going to resolve vertically. So when we resolve vertically, so we shall have the T and this and the mg. So it should be t sine 30 plus the t and then minus mg, because it is acting in the opposite direction, is equal to 0. So t plus sine 30, t sine 30 plus t is equal to mg. And then we substitute in the value t. Remember, we had already got it as 9.24. So when we substitute in, and this, remember we wanted the weight of the bead, and we know that weight is equal to what? To mg. So that is why we are stopping here for the weight as mg. So it will give us 13.86. Is that clear? Any
Yes.
questions? Okay, if there are no questions, let me... So briefly, that is what we had to discuss today. I didn't prepare an assignment for today, but I'm going to prepare it and send it on the WhatsApp group. And then some of you should do it. But most of you don't do the assignments because like what I gave in paper 1, there are only a few individuals who tried to do that. But you should always do, because in math it is practice that makes you perfect. Allow me to conclude by saying some few things about our services. So our online classes are 500, and those include student-teacher interaction by holding class engagements, access to subjects and content on the website, yaaka.cc. So marking and grading of assignments, quizzes that you do. So all of that goes for only 500,000 per year. In case of downloads of subjects, a single subject is 10,000. For example, if you wish to download mathematics, it is 10,000. All subjects per class in primary, if you have some of your sisters and young brothers, it is 30,000. And in secondary, it is 50,000. So those ones are accessible on those two websites. So access Yaaka through https://www.cca.yaaka. Then you also have access to Educare. And on Educare, you only have access to content, which is in 4 levels. So bronze level is 20,000, and that one is paid every month. So if you wish to only be on monthly basis, 50,000 is for quarterly. That means for every 3 months. 70,000 is half a year, and 100,000 is per year. And in case of any inquiries, you are free to call on these numbers there on that flyer. Otherwise, thank you very much for listening and for your active participation. We look forward to being in contact with you.
Thank you, Teacher Ashaba, for teaching math. Colleagues, today we have more lessons. We have ICT. You can see the timetable very well. We have ICT. Those who studied very well, it is at what time? It is at exactly 12. So be there for ICT. And then at 10, we are trying to give a training on how our system works. So in case you can tell your parents or yourselves to be available, we shall share the link in your group. So you can be available and attend to that training and see how best you can continue with digital learning. Good day.